So today I'm doing a bit more work on this refrigeration system. I've been experimenting with capillary tube lengths, and this is the length that was on it before. I'd actually shortened it a little bit and got the low side pressure up to about just under 15 psi. It's all under vacuum just now. So what I've done is put this longer capillary tube on it. It is longer, but it's also wider inside, and it's not as restrictive as the other one. And what I'm doing here is putting a suction line heat exchanger on, so that involves just soldering or brazing the capillary tube to the suction line in the compressor. So the liquid comes from the condenser after having went through the filter dryer, and it just goes along the capillary tube on the outside of the vapour return to the compressor. And what that could do is, if there's liquid coming up here from the evaporator, the heat of that capillary tube there can evaporate that liquid off and stop it from going back to the compressor. And I think in some cases it improves system efficiency, but I don't know if that's true or not. So it's all under strong vacuum just now. This is my new vacuum pump. This compressor came out of a dehumidifier, so it's what's known as an HBP compressor, high back pressure. It's intended to pump quite a lot of refrigerant, and it's like for suction pressures in excess of 30 psi, whereas a low back pressure compressor is for things like for use in freezers where you've like maybe got 10 psi or less on the low side. So it pulls a very good vacuum. I've also taken the polyester oil out of it and replaced it with mineral, because polyester oil turns to acid when it gets too much moisture in it. So that's all out of there now. And while it's under vacuum, I'll continue soldering that capillary tube onto there, and it shouldn't oxidise the inside of the tube very much at all, because there's no air inside it. If there's any oil on the inside the tube, it won't burn, but it'll probably decompose. That's the only problem, but I don't think it will do any harm. I've done this stuff so many times and it's never damaged a compressor, not yet anyway. The only time I've ever destroyed a refrigeration compressor is when I was using it to compress natural gas into this container here. I think it was about 2 years ago I did that, and I think I had the pressure up to about close to 60 bar, and it just destroyed the valves inside the compressor. So what I've done is I've just filled it with refrigerant. The compressor is roasting, and the reason is because it's designed for R12 and not for R290, so it's operating well without its out with its design specifications. So I've just basically running it under very little load just now. There's not very much liquid in there. I've siphoned it all into this bucket here, and the suction line heat exchanger, it does do a little, I suppose. I think there's some liquid going back in the compressor, not very much though. It is frozen right back to the compressor just now, and I'm just doing that just to try and cool it down a bit. But I think the suction line heat exchanger is doing something, because if I was to pour all the liquid back into that bucket again, all that ice would go away. So I could try that just now and see what happens. So yes, it is obvious that the suction line heat exchanger is working, and yeah, it's because the whole thing, this whole little coil here, is freezing. And the coil's not for any other purpose rather than just to keep things neat. It doesn't do anything else. Capillary tube is often just arranged in a flat spiral sort of thing, just to keep it neat. But as you can see, it's frozen there, the capillary tube, but it's not frozen here. This is where This is where the capillary tube just comes from the filter dryer, so it gets colder as it goes along, and that results in the refrigerant in there being very, very cold here. So I'm going to pour the liquid back in here and see what happens. Right, so pouring in the liquid now. So the suction line to the compressor defrosted quite promptly there. And some of the ice has disappeared, and it still is disappearing. And these are our pressures, which the system seems to stabilise at mostly. So I reckon I'm running the evaporator at, well, close to maybe -20. So, which is still a bit cold for the application, but if I wanted to run the evaporator, say at like -5 Celsius, I'd have to use this compressor here. And that was originally out of a dehumidifier, as I said before, and it could probably move more heat. It's more suitable for this sort of purpose. But the only reason I'm using it as a vacuum pump, because it makes a very good vacuum pump. So I'm pretty much done with my test. The low side pressure seems to stay at about 20 psi, so I'm quite happy with that. And it's actually freezing the antifreeze, but it's quite a weak solution. It's only down at -7 or 8 Celsius, so it's not all that cold really. I'll need to make the solution stronger so this can work better. So what I did was I chilled down this small tank here. I chilled it. I had it in the bath, and I'm going to get this fire extinguisher refilled. And before I do that, I just transferred some of the CO2 from this into there. And to do that, I used this, and that came off a CO2 regulator, and I've soldered a piece of copper pipe on there as an adapter. Then there's capillaries tube, and then there's a copper flare fitting on there which attaches to the small tank. Then I transferred the CO2 through the capillary tube, and because this tank was much colder, it all went in really nicely. It's very, very difficult to hear. I can even barely hear it myself, but there is a liquid in there, and that's the pressure in the tank just now, but that will no doubt increase. If this tank was to hit 30 degrees Celsius, the pressure in it would be over 90 bar. But this tank could take quite a bit more than that. So all that's left to do is just insulate this, because it just gets covered in frost and then just drips water everywhere when it thaws out. So I'll need to look at that. Insulating it will also make the system more efficient. And this is what it looks like with all the insulation on. So it should consume a little bit less power, hopefully. Not much though.